Okay, so we have to determine whether or not this function is continuous and differentiable at x equals 2. So I ramped it up a notch because the last one was a little bit too simple, folks. So first of all, does the function exist at 2? So 2 squared plus 2 minus 7. 4 plus 2 is 6 minus 7 is negative 1. So I'm going through this part a little bit faster now as we've gained some proficiency of justifying continuity. So 2 from the left would be 5 times 2 minus 11, which is negative 1. And we know that the limit as x approaches 2 from the right is also negative 1. Oh, this is good stuff. So then f of 2 is equivalent to the limit as x approaches 2 of f of x. I must go all 3 steps to prove continuity. Notice the notation, people. Okay, now let's prove if it's differentiable. In order for a derivative to exist, the limit must exist. So we must look at the limit from the left and the right at 2. So we'll first start with the derivative at 2 from the right. So that will be the limit. And yes, let's use the traditional definition to get a little better at it. So h approaches 0. So it's going to be a quantity squared plus a quantity minus 7. Okay, just trying to help you out with those x plus h's. So since I'm approaching it at 2, so I'm going to have 2 plus h squared plus 2 plus h minus 7. And then minus, I substitute 2 into that expression. 2 squared is 4 plus 2 is 6 minus 7. Well, we already knew that was a negative 1, didn't we know that, Clyber? Okay. Now, the part we haven't done so much, now I'm going to finish this problem and evaluate and find the limit as h approaches 0. Well, this is just some good algebra, folks. So 2 plus h squared is 4 plus 4h plus h squared plus a 2 plus h minus 7 plus 1 all over h. Okay, is there anything here that we see that will reduce out? Notice I keep writing the limit as h approaches 0 until I actually plug it in. Well, look at this. I have a 4 plus 2 is 6 plus 1 is 7 minus 7. Great, that makes a 0. And the rest of the terms, now I've got a 4h and a 1h, so that's 5h. So I have h squared plus 5h all over h. Now, if I were to plug 0 in at this point, I would get indeterminate. So I know there's more work to be done, and I can see that there's a common h. So h plus 5 all over h, and the h is reduced out. Now I can plug in 0, and I get 5. So that means the slope of the function from the right is 5. Now, will the slope of the function from the left also be 5? If so, then this function is differentiable. So the limit as h approaches 0, and this function is 5x minus 11. So I'm going to have 5 times something minus 11. Then minus, when I plug in 2, we already figured out that's a negative 1 all over h. And since it's at 2, we're going to have 2 plus h. So we're selecting a number just slightly above 2. Now let's do the algebra and let's simplify and combine like terms. So I get 10 plus 5h minus 11 plus 1 all over h. So 10 plus 1 is 11 minus 11. Woohoo! Love that. And then also I notice that there's an h in common. Well, I won't go too fast here. Limit as h approaches 0. I have 5h over h. The h reduces out, so I end up with 5. Woohoo! So that means the slope of the tangent line as x approaches 2 from the left, 2. Copied that down wrong. 2 from the left also is 5. So yes, this function is continuous and differentiable.